All right. Cool. So, determinant. What this allows us to do is determinants allow us to find x, y again if we use it a certain way. Okay. Determinant. Now notice, let's say I have this matrix. 2, 1, negative, 3, 6. Okay. First off, the only time I can have a determinant is if it's a square matrix. That's the only time I can do a determinant if it's a square matrix. It has to be a 2 by 2, okay, or 1 by 1, or 3 by 3, and so forth. It has to be a square matrix. Okay? And notice, guys, something that we're going to see is the notation of, it looks kind of like absolute value. That notation of straight lines instead of brackets says find the determinant. Okay? So this tells me to find the determinant. Okay? And the determinant was, when you guys did the inverse, you guys remember doing the AC minus the DC on a 2 by 2? That's a determinant. Okay? So in our case, remember if I had A, B, C, D, the determinant is AB minus B. Okay? So, what would be the determinant of matrix A? There's a couple notations I could say. You could say find. That would denote determinant. Or it could be the DET of A. Those are ways that you just might see that. Okay? Or they might just have it on there with the absolute value type looking matrix. Does that make sense? You might just say find. Okay, so what would ours be? What would be the determinant of matrix A? Well, we have 2 times 6 is 12, minus a minus 3, right? Which is 50. That's a big age difference. Okay, so 2 by 2 is really simple. It's a really easy way to go ahead and find the determinant of AB minus BC. Really, really simple. Okay. When we get to a 3 by 3 or 4 by 4, it becomes a little bit more interesting. So what we're going to do is such. Here's a matrix. Okay, here's our matrix. We're going to find the determinant. We'll call him A again. So it might just say find that. Now in a 3 by 3, or even larger, what you have to do is take a row. Okay? Or a column, it doesn't matter. But I would like you to understand where some things come from. Okay? Actually, we'll do that in a minute. What row or column looks kind of nice? I have no clue what's going on. But the row or column I would use is either this column, okay, this one right here, or I'd use this row. Anybody tell me why? It has a 0 in it. Okay, if it doesn't have zeros in it, look just for numbers that are nice and easy. Okay? But what happens is, when you go ahead and find a determinant of a 3 by 3, is you take a row or a column, and then the elements of that row or column become scalars. You guys remember what scalars were? They're the numbers on the outside of the matrix, right? You find square. Does that make sense to everybody? Okay. So I'm going to go ahead and use that first column that I have there. 2, 0, negative 2. Okay. So what you do is you take that row and put the numbers. So 2, 0, negative 2. Okay. And then you eliminate the row and the column of that element. So for example, if I was doing that first number 2, what row and column does it have? It has this row and this column. You guys see how that's in there? Both that row and that column. So therefore, do you guys see this little 2 by 2 left over? That is what I will write, and I will find the determinant of that little 2 by 2. Okay? Now, ladies and gentlemen, I'm going to do it again. I'm going to undo this just one more time just so you can see it better. But does everybody understand where I have that little matrix? And I'm going to show you another way. I prefer it the other way, but I just don't know what they're expecting on the text, so I'm showing both. Okay? Oh, nuts. Gotta get rid of that. All right. So once again, we had basically these 4 numbers right here, right? 2, 4, 5. Correct? Yeah.
So what would happen if you do 4?
I'll show you. I can do both. Now, I'm going to find the determinant of this and then times it by 2. Okay? Now, do you see why I want to have a row with a 0 in it? Because what's 0 times the determinant? 0. So that doesn't, it makes me really, I don't have to find anything here, right? I can just skip that one. Does that make sense? Okay? But right here, what would be the determinant of negative 2? So therefore, I would get rid of this row, that column, so I'd be left up here, wouldn't I? So I'd be using 3, negative 1, 2, 4. Okay. Now, I don't know what I'm doing here. Does that mean I add all these together? Do I subtract all these? I'm going to show you how this comes about. This is the key part of today. What element is this? What would we call this? We call this element 1, 1, correct? What's 1 plus 1? 2. So that's negative 1 squared. And what's negative 1 squared? 1. So therefore, this is just whatever it is. Okay? I'll do a little thing right here. What element's this one right here? Second row, first column. Right? So this is 2 comma 1. Does everybody understand that? Element second row, first column. So notice when I add 2 and 1 together, I get negative 1 cubed. And what is negative 1 cubed? Negative 1. So this is negative up there. What element is this guy right here? 3 comma 1, right? Everybody there with me? So I add those together, I get negative 1 to the 4th. And that gives me 1, so I just do whatever it is. So it's negative 2. Okay? When we do this one, I'll show you just the opposite. Just bear with me for a minute, guys. I know right now it's like, what the hell's going on? But it's a very simple process. Yes. Because what happens is it teaches you that here's a 3 by 3. So when I use the 3 by 3 and I do the determinant, it has this pattern. And the reason why I use this pattern is using those elements, I raise it to that power, and that tells me whether it's going to be positive or negative. And it's the hardest part for me to explain why, because I'm not really sure. I'll be honest. So, oh notice you're always opposite sides. So what would it look like on a 4x4? You know? It'd go plus, minus, plus, minus, minus, plus, minus, plus. Does that make sense? It looks like a checkerboard almost. But the reason where these come from is, notice this would be element, once again, what would that element be? Row 4, column 4. So 4 plus 4 is 8, that's negative 1 to the 8. Negative 1 to the 8 comes out as a positive. But what I do on these is that sign goes in between. Notice I have a plus, minus, plus, because I'm using this column. So if I was talking with Jacob, Jacob asked, what if I use this one? I'll show you that in just a second. Okay. Okay. So, here's what we have. What is the determinant of this guy? 12 minus 20, right? Correct? 12 minus 20 is negative 8, times by 2 is negative 16. I didn't have to do anything here because that was 0, so that's minus 0. 1 second. Then I have negative 2 times 12 minus a minus 2, because it's going down and then across. So it's AB minus B. 12 minus a minus 2 is 14. Negative 2 times 14 is negative 28. So the determinant of A is negative 40. Okay? That number will then help us a little later to help solve the equation called Cramer's rule. So let's go now back and use that other row instead of the column and see if we still get the same determinant. Okay? All right. Let's go ahead and write that matrix again. Can somebody tell me where it was? 0, 2, 4. Negative 2, 5, 6. All right. So this time, it's like, what if we use this row though? What if we use it? Okay. So we go ahead and put our numbers. What are our numbers? 0 times the determinant of that. So remember, get rid of the row and the column that he's in. What numbers are left over? 3, negative 1, 5, 6. Does everybody understand what that's left over? Because we eliminate him as well. Right? But once again, did I really even have to do anything on this guy anyway? Did I even have to sign things first? Why? Because he is 0. Okay, then I'm going to use this 2. Okay, once again, getting rid of the row and the column. Row, column, so that's 2, negative 1, negative 2, 6. Then I have 4. And that with that 4, row, column, 2, 3, negative 2, 5. All right, but now I need to know what signs go in front of these, right? Because I'm in the second row, once again, this represents 2, 1, 2, 2, and 2, 3, right? So if I add those together, 2 plus 1 is 3, negative 1 cubed. Christian. So I couldn't get, so once again, guys, we're going to look at it. So because this is 2 plus 1, that's 3, negative 1 to the third is negative. This would be negative. 2 plus 2 is 4, 1 to the fourth is, negative 1 to the fourth is 1, so you would be positive. 3 plus 2 is, 2 plus 3 is 5, negative 1 to the 5th is negative 1. So this should be a negative. Agree with me on that. Remembering, if you just remember that checkerboard pattern though, you really don't have to remember negative 1 raised to the power. Just understand that's where it's coming from. But plus, minus, plus, minus, plus, minus, so therefore we might negative, positive, negative. Greg, I never came back to this one. I'm sorry. Okay. I apologize. And then this would be plus, minus, plus. And I can show you why the determinant of a 2 by 2 is the AB minus BC. Okay, what's 0 times anything? That's the nice reason why we use that row, right? Is everybody there with me? Okay. This is 12 minus 2. Because I have 12, negative 2 times negative 1 is 2, so 12 minus 2 is 10, 10 times 2 is 20. Yep. This guy right here is 10 minus a minus 6, so that's 16, huh? 10 minus a minus 6. Okay, so that's 16, but 16 times negative 4 is negative 64. If I add those together, what do I still get? Is that the same determinant as I had last time? It was, right? So the determinant is pretty easy. It's not that hard. You could do this. This is called minors and cofactors. Okay? They could ask you specifically. 0, 2, 4, negative 2. Okay. So once again, we could have this matrix. They could ask the determinant for just one specific element as well. They could say, please find the minors and cofactors of 2, 1. Round sum. Let's not be too clear. Let's do 3, 2. So, what that means is by using the third row, second column, okay, the number would be 5. With the determinant, remember, get rid of the row and the column, correct? Does everybody understand that? Third row, second column. So I'll be using the third row, second column, right? So that's the 5. Now notice eliminate the row and the column and the row, so I'd be left with 2, negative 1, 0, 4. Now, the only thing I need to ask is this exactly the way it is, or is it the negative? Remember, this is plus, minus, plus, minus, plus, minus, plus, minus, plus. So because it's the negative, this will be the minus. Okay? So what would be that specific determinant? Negative 5 times 8 minus 0, which is negative. Okay? Right.
Okay, question. Did you actually?
Uh-huh.
Okay, so
Right here?
or yeah, I just want to see. Okay, 2 things though. So one, you can pick any number,
Any row, any column.
You could pick like 2 for example, and go like that.
So I could pick, if I wanted to use this row, I could. Or if I want to use this row, this column, I could. If I wanted to use this, you can use any of the 9 ways you want to see it. The 3 rows or the 6 rows. Okay, that answer your first question?
Yeah, and then so once you pick a row, you have to do all the numbers in that row.
Yes. To find the determinant of the whole matrix. Now they might ask you just to find the minor using like what we just showed you.
Yeah.
Right? They might ask you that. But the real goal is to find the determinant of the type. Okay, folks? problem. I'm trying to a little bit outside my box here. How did I get the 2 negative 1, 0? So I found M32, which is here. Let me highlight it to say, ooh, that doesn't help. That was the 5, right? So that's the element. Now, what row and what column are being used? Well, I can't use him or him, so 2, negative 1. Does that answer your question? Yes.
So on the other problem, us doing different rows and getting the same number, like what that proves.
That proved that it doesn't matter which row I pick or column. I can use anything I want and still get the same determinant. That's basically it. So if I pick this column, which I did the very first time, I got negative 44 as the determinant. If I pick this row, I'll get negative 44 as the determinant. You don't have to do it more than once on a problem. I'm just showing you it doesn't matter which row. Does that make sense?
Yeah.
A little bit more. Okay. Okay. I'm going to show you one more time another way to find the determinant. This is my favorite way if you can be organized. Okay? Most of you guys are more organized than I am, but this is my favorite way. One more time. Okay. Now, if you recall, when we did a 2 by 2, didn't we basically subtract 2n? We took this and subtracted this, right? That was our determinant. Would you guys agree with that? Well, how can I do that with a 3 by 2? So what I do is I continue just to add the first 2 rows along it. Okay? And I'm going to do just like the 2 by 2. So I'm going to take the forward slashes, if that makes sense, and subtract the back slashes. You guys are like, I don't know what the hell that means. Let's see right here. Here we go. We're going to take this forward slash with those numbers. If I multiply those numbers, what do I get? 2 times 2 is 4, times 6 is 24. Okay? I'm going to add the next column. What does that add up to be? 3, not add, but times to be. 3 times 4 times negative 2. Negative 24. Plus. What do we get there? 0, right? Because negative 1 times 0 times 5. Yes, ma'am. Get first 2 columns and put them on, just so that I can get this in the main, so I can see what's on the diagram. Okay? Yeah. No, not done yet. We're not done yet. Now, just like we did on the 2 by 2, notice I took the forward slashes and subtracted the back. Does that make sense to everybody? So now I'm going to subtract this number, which is that guy. So negative 1 times 2 times negative 2 is 4. That guy. 5 times 4 times 2 is 40. Do you have a question where I'm at? And That one's 3 times 0 times 6, so the zero's in there, so that just makes it really nice. It's your 0. Okay. So, what do we have here? 24 plus, minus 24 plus 0 is 0. Minus 4 plus 40, 44. You have to determine it the same way, all the same number, 3 different ways. Okay? Any questions there? Yeah.
Okay, does it matter, what order we go for in the issue stage? So for example, when we do the backslashes, does it matter if we start at 3, or 6?
As long as you get all 3 back.
Okay. And could we solve for inverses between this at all of it?
This is just solving, this will help us find line EDR. And the reason, ladies and gentlemen, let me just show you again. The reason, remember, to find a determinant, okay, you pick a row or a column, right? I'm going to pick this row. Okay? So notice, I have A times the determinant. What's left over? What number is left over? I get rid of him and him, D's left over, right? What's the determinant of D? It's D. So AD, right? Now, because he is 1, 2, that makes him a negative, because remember this is plus, negative, minus, plus, correct? Because it's a pattern. So that makes him a minus. Then I take B times the determinant. Well, row, column, so C's left over. And that's why that's how you find the determinant of C. The same idea. Okay. Yeah. Scroll up. Okay. All right. So what this all helps us do is to solve an equation. Okay, and it's called Cramer's rule. Excuse me. Let me just get the equation to solve. Okay. Here's what Cramer's rule says. First off, you kind of put in as a matrix equation. Okay, once again, how do we write the matrix equation? 2, 6, 1, 8. Right? X, Y. Negative 1, 2. Any questions there so far? We all should know how to do that matrix equation, right? Now, using our inverses, we were able to solve last time, but this time we're going to use Cramer's rule. So I'm going to call this matrix A. Okay? And what Cramer's rule tells us is I need to learn how to find the determinant of A. Sometimes it's written as like such. Okay. And then we're going to find the determinant of AX. So I'll explain what that means in just 1 second. And then I need to find the determinant of AY. Okay? And what Cramer's rule says is that Y is equal to determinant of matrix AY over determinant of matrix A. X is determinant of matrix AX over matrix determinant of matrix. I know you might, it's really simple. It might look like a little bit harder than. Okay. All right, let's go ahead and find all of these items. Let's find the determinant of matrix A. Who was matrix A again? Can somebody read that to me? 2, 6, 1, 8. Okay, so what would that be? 16 minus 6. Can we see that? Forward is 16. Backward is 6. Feel good with that? Any questions there? Okay. Now, what does the determinant of matrix AX look like? Okay, what we're going to do is what was the answer? What did these equations equal? What was the two equal things? -1 and 2. We're going to put the answers in for the x column. So we're going to replace the x column, right? And we're going to put in the answers. Does that make sense to everybody? Okay, so -1, oops. Sometimes -1 and 2, 6, 8. Okay, you guys notice that I put in the answers in for the x column. Yes? Well, remember, what does this really mean when I wrote the matrix equation? It was 2x plus 6y, wasn't it? X plus 8y. So therefore, I would place the x column with the result. Does that make sense to you? You understand that these are the x values, the numbers in front of it, that, and then you just put your result right in front and where they were at. Nope, I didn't switch them, because remember, do you see up in your equation, look on your paper, because it's not, I don't have it on mine. You see on your matrix equation, what did those things equal? -1 and 2. I replaced the x column with those results, the answer. You see that? Where's our equation? Right here. So I plug this in for the x column. Okay, make sense? Yes. Okay, so I'm putting the results, the answers, in for the x column. So instead of 2, 1, now that 2, 1 is -1. Is everybody with me on that? Any more? Because that's how you solve this. If you don't get what the hell I'm doing, that's not going to help you, right? So once again, I had 2, 6, 1, 8, xy equals -1, 2, correct? I'm putting the solutions in for the x column instead of what the x's were. Okay? Okay. That one down. Okay. Now let's find the determinant. What is it? -8 minus 12. By the way, this was shut off today. What is -8 minus 12? Okay, let's try and find matrix AY here. What do you guys think that means? You're going to put the result and substitute it into the y column. Does that make sense to everyone? So I have 2, 1, -1, 2, I believe. Is that correct? Yes? You guys see how I put the answers into the y column because I'm looking for y. Okay. Any questions? We're almost done, like, I know it just, then you just gotta practice it, but we're almost done on understanding what we're really learning. So then this is 4 minus a minus 1, which is 5. Okay, now, what was y? And what was x? Well, y is determinant of ay over determinant of a. What was determinant of ay? What was the number we received? 5 over 10, so therefore y is okay. X is ax over a, which is 20 over 10, which came out to be 2. Was it negative 20? Sorry about that. Thank you. So negative. Let's go plug it back into the original and see if it works. X was negative 2. Y was a half, I believe, correct? Negative 2 times 2. Negative 4, right? A half times 6. Negative 4 plus 3. Negative 1. It checks out, doesn't it? Okay. Just another way to now learn how to solve a system of equations. Now you guys have learned 5 different ways to solve a system of equations. Okay, we've learned just elimination like we've done before in the past, right? We've learned doing a reduced row echelon form, row echelon form. We learned how to use inverses of a matrix equation, right? Find the other side. And now we use Cramer's rule. 5 different ways to learn how to do this. Okay. Let's do a 3 by 3. Okay, let's find, we're going to call this, we're going to find b, the determinant b, just a regular one, okay? I don't want to have to write the matrix equation again, we're just going to go straight into it, that'll get us together. So, the determinant of the 3 by 3. So I have 2, negative 3, 4. 1, 0, 6, 3, negative 2, 0. Any questions on how I have those with just a regular matrix B determinant? Here we have a 3 by 3. We could use minors and cofactors, which is taking a row and then getting them down into the 2 by 2. Or we could extend the 2 first columns and do the forward slashes minus the backward. Okay, I'm going to practice. I think I can do it both ways if you want, but I would like to practice on minors and cofactors, just because that's something that you might use more. I don't know exactly, once again, what it looks like yet. So which row and column do you guys want to use? It's a nice one. I'd use that 1, 0, 6. If we have a 0 and we have a 1, That's pretty nice, isn't it? Is everybody there with me? Okay. So, notice though, this is the negative, positive, negative, correct? Does everybody remember that? Yes? Okay, here we go. So I have -1, determinant. I'm going to get rid of the column and the row. Column and the row that that element is in, correct? So I have -3, 4, -2, 0. Now the reason why we probably picked this row is because we have a 0 in it. Huh. So I don't even have to do something else there because 0 times anything becomes 0. Are all your matrices going to have a 0 in it? Not necessary. Okay. All right. Then this guy is going to be a -6. Okay. Get rid of the row and the column of that element. And I will have 2, -3, 3, -2. Any questions on that? I have that. You good? Okay. Thanks for saying. So here's what we got. -1 times -3 minus a -8. Everybody see where I got that from? Oh, that's 0, isn't it? That's impressive. I like that one. Because 3 times 0 is 0, right? Then -8. So this is just 8. -6, parentheses, -4 minus -9. Okay. So that comes 8 plus 9, so that's 5. 5 times -6 is -30. So therefore, D is -22. And that's how much? Let's say, well, so that's -8. Man. Good job, Craig. -38, is that better? Thank you, Craig. Okay. Any questions? Now that's just D. Now we also have to find who else? dx, dy, dz. Okay, we gotta find all three of them. Yes? What does dx mean? I'm going to replace the answers for the x column, correct? The answers for the x column. We agreed on that? So as I look at this, I'm going to plug in 1, 0, 5, -3, 0, -2, 4, 6, 0. Ladies and gentlemen, I don't know about you. I'm definitely doing minors and cofactors and not extending with 2 odds. Can anybody tell me why? Look at our freaking row. Just staring right at us, right? A 0, 0, 6, that's really nice. Would you guys agree? So therefore, I'm going to use that row. Okay. With that being understood, this is negative, positive, negative. Does everybody understand where I'm getting the negative, positive, negative from? Okay. So really, the only thing that matters is -6, determinant of the elements that are not in its row and column, correct? So that's 1, -3, 5, -2. So that's -6 times -2 minus a -15. That makes it a plus, so that's -6 times 13, which is -78. Okay? Any questions there? A little bit tedious, but it's possible. possible, right? It's not very hard, it just takes some time. Right? Did I mess up or am I okay on that one? Because I mess up. Greg pointed out. Okay, let's find dy. So what are we going to do this time? We're going to replace the y column with the answer, right? So I have 2, 1, 4, 1, 0, 6, 3, 5, 0. You guys see how I replaced the y column with the answer? Correct? Now, does that really have any great rows or any great columns for us? Yeah, we have some nice ones. How about we switch it up this time and go ahead and do the backslash and the forward slash? Is that okay? So I'm going to go 2, 1, 1, 0, 3, 5. I'm going to go ahead and do the forward slash, which I get 2 times 0 is 0. 1 times 6 is 6. 6 plus 3 is 18. 4 times 1 is 4. 4 times 5 is 20. So that's what we have on our forward slashes. Now on our backward slashes, 0, 60, and 0. 0, 60, and 0. Either way, not too hard to take it the whole time, right? Okay, so therefore I have 38 minus 60 is getting negative 22. So far I'm getting all the way. Yes, sir.
Oh, wait, never mind.
You found it?
No, I was can't believe
The last one, what are we going to do for the last one? We're going to find dz, right? By the way, I would guarantee you're going to be solving via Cramer's rule at least once on your test. It's a big enough rule that they care about it in the core that they specifically mention it. So I would really suggest that that's what's going to come out. Okay, you guys tell me. Should we add the 2 rows or should we do minors and cofactors? I would do minors and cofactors. There's another row just staring right at us, right? Does everybody see row 2 just like bang, 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 bang? Yeah? Okay. So, once again, eliminating the row and the column of 1. Notice, is he going to be a plus or a minus 1? Minus, good, because remember this is the minus plus minus row, correct? Now, it just so happens we keep picking this row. Is it always going to be the second row? It could be anyone that looks nice, right? So negative 1, so that's negative 3, 1, negative 2, 5. So we get negative 1 times negative 8 minus a minus 2, which is negative 1. Oh, that's negative. What the hell did I get 8 from? Holy hell, people. Negative 15, is that better? Minus a minus 2, which is negative 13, which comes out to be 13. Now, I don't know about you guys. I'm going to show you why sometimes I love Cramer's rule. Was that really any really difficult math? Notice, could you imagine doing this by a 3 by 3? Once again, what was D? D was 78. Oh, or was that DX? DX was negative 78. dy was, and dz was 13, and then d was, do we have these numbers? Is this all the numbers we have? Okay, so what is x? Dx over d. So therefore, that is negative 78 over negative 38. That, by the way, they don't go in nicely. That's 3919. How many of you guys would have loved to solve a freaking row by row situation with 3819? See what there's sometimes reasons why maybe one system might work better than another, right? Okay, what's y? dy over d. And dy over d is negative 22 over negative 38, which is 11/19. Once again, not something I'd want to play with, right? And then z was dz over d, which was 13 over negative 38, which is negative 13 over 38. Okay? We have now solved for x, y, z in there.